inside this bag is a probable solution to a problem that I have had with my Antweight combat robot nylon brigade since the very beginning. So let's take a look what's inside this bag. So these little things here are called shoulder bolts. They're a special type of bolt that has a thicker rod section and a smaller screw section. And no, there's no way I can describe that without somebody snickering, so let's just leave it as is. I'd never heard of these things before until a few months ago when I got a comment by Bammy2 on a video talking about Nylon Brigade's wobbly wheel problem. So all this trouble is because of these two little things right here. These are the bearings that sit inside the front either wheels of Nylon Brigade. There's two of them in each of the wheels. Now I chose these particular bearings because, well, I wanted to share some common parts between Nylon Brigade and Microflash, my Ep01 combat robot, which has not fought in like 5 years now. And these little bearings here have a 4mm inner diameter. So let's come back in close and take a look at why that has been such a problem. So originally, Nylon Brigade ran a hex bolt right here. This is an M4 hex bolt as a shaft for the either wheel. And my thought was that an M4 bolt was actually 4mm in outer diameter, and therefore it would match the bearing, but that's not correct. An M4 bolt is actually like 3.5, 3.6mm of outer diameter, which meant that there was a lot of slop with the 4mm bearing, and it was enough that the drive belt would pull on the wheel, tilting the either wheel out of axis or misalign it relative to the drive wheel and back, which would be a great way for the drive belt to pop off in the slightest impact the robot took. So my solution last year was to drop down to an M3 bolt and create this custom 3D printed sleeve that increased the outer diameter of the bolt to 4mm. Now this worked, and it worked fairly well, but these pieces are kind of finicky to print. I'll put a link in the description below to a video talking about that process, but the short story is, well, when I import this model in the Cura, if it's not set to the exact proper scale, because it wasn't proper to get the scales correctly inside Blender, this piece would either come out just a tiny bit too big or a tiny bit too small, and it would not work. And I'm talking the scale had to be exact. 1% off either direction, we had problems. Now you may notice here that the shoulder bolt that I'm using now, that its kind of smooth rod section is shorter than the sleeve from last year. And the reason for that is this particular size of shoulder bolt is really easy to get a hold of. The longer size that would match up correctly with the existing wheel set, they're out there. They would just take like a month to get here, and I didn't want to wait that long. What I need to do is to design a slightly modified version of this wheel. And here's the test print. If I put it right next to each other, you can see that it's just a tiny bit shorter. But the main difference of to hold these things up is that this piece right in here is inset a lot more than this piece. So therefore the actual length of the shaft is going to be a lot less on this particular wheel. So let's get the bearings over here and to see how well this thing works. That's pretty good. There are a few more changes that I need to make to this hub design here before I can call it done. The first is that I want to reduce the diameter of the hole that holds the bearings by a tiny little bit. I'm talking like maybe 0.1mm. Now when this piece is made out of nylon versus PLA, as a test piece here in my hand is, the nylon is a little bit softer and it allows a little bit more slop of the positioning of the bearing, and the bearing itself can kind of rotate a little bit within its seating position. So hopefully by making the fit a little bit tighter, that won't happen, and it will make the final rotation of this wheel a little bit smoother in the final robot. Next thing I want to do is reduce the width of the drive belt section. Right now it's almost, twice as wide as the actual drive belt itself. And that's probably a little bit overkill, so I can reduce that and save a little bit more weight. The next problem I have is that the head of the shoulder bolt happens to be pretty much the same diameter as the outer diameter of the bearing, which therefore if that shoulder bolt gets into the area where the bearing is supposed to be, it adds a lot of friction to the wheel and slows things down. So what I need to do is create some sort of very simple washer. In this case, it's going to be a very thin nylon piece that'll therefore keep the head of the shoulder bolt out of the actual bearing area of the hub. And then finally, because of how the hub for the drive wheel attaches to the motor and all that fun stuff, it pushes the 3D printed hub out from the body a little bit. I need to create a spacer that's the same diameter that can go ahead and sit in between the chassis and the idler wheel, and therefore make sure the belt stays lined up correctly between the idler wheel and the drive wheel. New wheels are done. They're sitting over here. I want to do a quick weight comparison with the old set right over here. The old set clocks in at around 34 grams for one side of the drive system. Now the new set over here, we're looking at only 26 grams for the drive system. That's quite a nice improvement. Now 16 grams total savings is really good, but the most important question still remains, and does it fit on the actual robot? And I'm going to try that out right now with the trashed out chassis from Michigan Mashup. New wheels are on and they fit all right. I say all right because the spacer in here that's between the idler wheel and the chassis is a little bit too big, and it's pushing the wheel out, causing belt misalignment and other fun stuff. But that's a relatively easy fix. Now the question you may be asking yourself at this point is, Jason, if the problem was with the weapon cage over here shattering on impact.
Oh, no, that's not good. It's broken up. Oh, that's not good.
Why are you starting to fix the robot with the wheels? And the reason for that is I gotta have one other problem taken care of first, which is that the ground clearance when the robot is inverted is very, very small. It's much smaller than the ground clearance of the robot when it's driving normally. And this is such a problem that when I put the lid back on the robot, I gotta be very careful how I install it. Otherwise, I run the risk of not being able to drive inverted. So to fix that problem, all I got to do is move the axis of the wheels up a little bit. However, because of the design of the robot, the axis of the wheels and the axis of the weapon shaft are all in one straight line. Therefore, if I were to move the axis of the wheels up without addressing the design over here of the weapon cage, then we're going to have some problems with ground clearance with the weapon. So let's start by jumping over to Blender for the last part of this video and get the axis of the wheels in the correct space, or at least a better space. All I'm doing here is taking the axis of the front wheel, moving it up by, I don't know, let's say 3 millimeters. That's probably good enough. And then I'm going to head to the back over here where the motor mount is and raise that up by a similar amount. And I think I should have enough empty space in there to still allow for my top motor mount cap brace thing that goes in there to hold everything all together. With that design change complete, I'm going to go ahead and print off a test chassis at some point, but that's going to be a little further off in the future because I want to make a few more design changes before I go ahead and do that because, well, I don't want to print off a bunch of test chassis and just waste time and material and all that fun stuff. So if you want to see the next few steps in the process, I get ready for the next competition, which is not too far in the future, so I got a bit of a time crunch here. Go ahead and hit that subscribe button. I'm Jason, the creator of Team Rocket Robotics. Thank you guys all for watching. Oh, and by the way, this is, I think I mentioned it, but this is Nylon Brigade, my Antweight combat robot, in case you haven't picked that up. Anyway, I will see you guys all next time.